Hello everyone, welcome back to my video series on solving LeetCode problems. I'm Alex, and let's look at the problem. So the problem is 334 increasing triplet subsequence. So what's this about? Given an integer array nums, return true if there exists a triplet of indices I, j, k such that I is smaller than j is smaller than k and the corresponding numbers are also smaller than each other sequentially. If no such indices exist, return false. So nums 1, 2, 3, 4, 5 is true, well, any triplet, because all the numbers are smaller. In this case, all the numbers are ascending. In this case, all the numbers are descending, so it's false, no triplets exist. In this case, it's true because it's 0, 4, 6. Okay. Okay, so let's see. So we just need to have one number that's higher than the okay, I think I know how to solve this. JS Paint. I think this is super simple actually. So this is okay, 40. So in this case, we could have 1, 5. Oh wait, we don't have. Actually, we have 1, 5, and then 6. That's pretty okay, I guess. We also have 0, 4, and 6, which is good. And we also have 2, 5, and 6. These are also valid, right? I think there are many valids here. Okay. Does I and j, well, they just need to be smaller, so they don't need to be sequential. So it can be 2, 2, 5, and 6. So that's possible. So how do we do this? I think we just need to iterate and check when do we have something growing. So let's just go and do something like, what is the minimum we can find? So we start iterating and then we find 2. And then we find 1. And then we find 5. It's like, okay. Now let's do something different. Okay, let's iterate until we find like a local minimum. And by finding a local minimum, it means that it's a number that will have a higher one right next to it. So if we iterate, we have 2, then we have 1, then if it grows, let's just keep the smallest of the bunch. So we iterate until we find a number that's bigger than the previous one, and we keep the smallest of these ones. So we have 1. Then we continue iterating until we find a number that is smaller than the next one. Well, no, actually not really. We don't need to do that. So once we find a local minimum, we need to save the next one is a bigger one. So it's like, yeah, okay. We have a 5, so you only need the one that's bigger than this. But then, oh, we just found another local minimum. Is it smaller than the one that we found before? Actually, it doesn't matter if it's smaller or bigger. Let's just keep it nonetheless. And then we continue iterating. And oh, we found 4. So this one, what can we do with this one? This one we can actually add to this one. And that's it. So we just need to add this one to the smallest one that we found. If this one is bigger than the smallest that we found, then the last one of the list of smallest, like we try to put it here, oh, it doesn't match, we put it here. Then we do the same thing with 6. We put it here, and we put it here. Okay, yeah, so we just finished iterating the array, and we found that actually that is true. We were able to form 3. So what do we need to do? We have local minimums, and those are, those are in the box here. So we found this value too. Is it a local minimum? No. So let's try to insert it here. Well, we can't. Found 1 is a local minimum. Yes, it is actually. So we put 1 there. Cool. Then we find 5. It's not a local minimum, so let's try to put it in front of one of the local minimums that we found. We actually can do it. 0, oh, it's a local minimum. Here goes local minimum. Then 4 is not a local minimum. So we just try to put it in front of all of those. Now it's done. So 6, same thing. Okay, once we found it, okay, done. Okay, so let's get to implementing. Where's my terminal? cd code cd leet make directory 334 increasing triplet code 334. And now solution.py. Okay, pass list, and now solution increasing triplet nums. Let's just use this one. Okay, so now we just go and set local minimums is a dictionary of key integer and a list of ints. Starts with nothing. So for num index and num enumerate nums, we just say, okay, so if num index is smaller than length of nums, it's smaller than length of nums, you can check if it's a local minimum. And nums of num index plus 1 is bigger than num, then do local minimum stuff. And else, actually, the local minimum stuff, and that is if num not in local minimums, minions. If num not in there, so minimum of num equals, I'll just start with we need to have like 3 of them, 3 elements, and so to finish it, let's start with the same one, just to make it simple for the next week. So for local minimum key in local minimums dot keys, if local minimums of local minimum key last element is smaller than number, then we append it. And num. If length of this is equal to 3, then return true. And return false if it never returns true, pretty much. So at this moment, let's just run the code. It's out of range. Num index 5 smaller than -1, of course. Return true. Right, let's see, local minimums. 156. Well, that's good enough. This is exactly what I was planning. Let's just submit and cross our fingers. Almost. Okay, this one false, expected true. 150413013. Actually, this is clearly something that can be true. So let me just run the code and check the local minimums. 15040413. Oh. Maybe I can see if I can replace them as well. So I can do something like, hey, I just found this one. Let me see if this one is bit smaller than the last one you have and bigger than the second last one you have, then maybe I can replace. So length of local minimums of that key equals 2, and so and local minimums of 0. So we know it's not bigger, but let's see if we can replace it. Minimums of 0. The first one is smaller than num, then we can replace it. So local minimums -1, or just 1 in this case, is going to be none. And now this will change to true. Yep. I hope this made sense. Yeah, so let's say we find this is a 5 here. No, this is a 4. So 1, 4. So we find 1, then we find 0. And it's like, oh, all good, then 4. And then we find 1. It's like, well, we've just found 1, so let's try to insert it. So we try to insert, let's remove this 6 here, because the 6 doesn't exist. Find 1, and what can we do with it? We try to put it here, well, it doesn't work, but wait. What if we can just replace it with this one, and it's still the same, and we have even better chances of using it, of finding a good number afterwards? Oh yeah, let's do it. Then we do the same with 5. Well, can we replace 5 with 1? Well, no, because it's the same as the one previously. It needs to be higher than this one, so never mind. And then we find this 4, and now we can actually put it here. And otherwise, if we'd still have the 4 before, we wouldn't be able to finish. Did I submit? Yeah, and it worked. So memory was good, time was not so good. Let me just submit again, see if we get better results. No, we got horrible results now. But hey, the logic works, so I hope you guys enjoyed it. See you later.